I'm like aide, and this is Math AD, where we combine math and alcohol to catastrophic results. So, today, we're gonna do an integral that looks like a real pain in the ass. And I'm going to show you that it's really not as much of a pain in the ass as it appears. So, here's one that's just about to buckle your brain. X to the 7th power over the square root of 1 minus x to the 4th power dx. Okay. First of all, what you're looking at here is this square root sign. You see how there's a square, and then there's something to the 4th power. But we can replace this x to the 4th power with a squared, and that can be squared, right? So what I'm going to do is, right, a 1 minus x squared squared. So we can probably do a trig substitution here and then see how it unfolds. So we're going to set x squared equal to sine theta. Okay? Now, since we have x squared equal to sine theta, we can work out our triangle, no? So we're going to draw out our triangle. I always make this my first policy. Always draw out your triangle. Instead of doing it at the end, do it in the beginning. So what we have here is sine theta is equal to x squared, which means opposite over hypotenuse equals x squared, which means opposite is x squared and your hypotenuse is 1, and that makes a whole shitload of sense. And you have here 1 over x squared squared, x to the 4th power. So now we have our x squared. We're going to take the derivative. 2x dx equals cos theta d theta. Now we're going to solve for dx. It's going to be equal to cos theta dx equals cos theta d theta all for 2x, right? Now we're going to take this stuff. We're going to substitute everything into here, okay? So, okay, look what we got here. You know what's really wild about this? That right there. 1 minus x to the 4th power. That's right there. And that is the adjacent over the hypotenuse. That's cos theta. So, we're going to have our x to the 7th power. Because what I like to do is if I see something that doesn't appear to make any sense at that time, maybe sometime in the future, it'll elucidate and it'll all make sense in the end. So I'm just going to leave that there because we still have this, right? And then we have the 1 over cos. What do we have here? That's a cos. Nope, that's not that. That is just a cos theta. And dx has been substituted by cos theta, d theta, all over 2x. Right? Look at this. Right? That crosses out. This 2, and take it into the front. And now, see this x and this x7? That goes out, and this one comes down by 1. Oh, things are starting to make sense. Let me rewrite this so I can show you what I'm talking about. Okay, so we have 1/2, and we have this x to the 6th power d theta, right? This has got to be theta, right? There is no mixing these. They're oil and water. They just won't cohabitate. But what we do know is that x squared equals sine theta. Because we set that out, right from the beginning with this triangle, right? So what we do is, well, if x squared is sine theta, then x to the 6 is nothing more than these cubed. So x to the 6 equals sine to the 3rd power theta, right? So now what we're going to do, we'll make that substitution. So, take that one out there, I'm going to make some space. And now we're going to write sine to the 3rd power theta d theta. It's like, okay, from here to here, we don't appear to be getting anywhere. Okay, what we're going to do is we're going to split the sine into two different signs. I'm going to split it into a squared sign and split this sine into a regular sign, theta d theta. And the only thing we can do here is maybe do a trig sub, right? Substitution, and use this identity is equal to 1 minus cos squared theta, right? Now I'm going to multiply these through, and maybe we might be able to do a u substitution to get closer to the answer, right? So we're going to have 1/2 times the integral of sine theta. And I like that part. So let's close that part of the integral by putting a d theta. And then we'll subtract 1/2 the integral of cos squared theta sine theta d theta, right? And you're thinking, okay, what's going on here, right? Whenever you see something like this, where there's a combination of, say, there's a cos, and you look over here and it looks like this, like the derivative, right, for cos. You're thinking maybe we can do a u substitution and we can make the sine go bye-bye, right? So what we're going to do is we're going to set u equal to cos theta, right? Okay? And then du is equal to negative sine theta d theta, meaning d theta is equal to du over negative sine theta, right? So now we do is, because there's a cos squared, that becomes a u squared, right? And now we substitute this d theta with du over negative sine theta, right? Right? And then these parts, they cancel, and you have this negative still sitting around, right? You just take it to the outside, turn that one into a positive. And now you have something very workable. So we have 1/2 times the integral of sine theta d theta plus 1/2 the integral of u squared du. Like, oh, look at these two things, two different worlds. So now what we're going to do, obviously, the integral of that is 1/2 times 1/3 u cubed, right? And the integral of this sine is a cos, right? But it's a negative cos. So we have a negative 1/2 cos theta, right? And now this becomes a 1/6. And now we have this u, right? What was the u? U was equal to cos. So what we're going to do is every time you see a u, you put a cos, right? So what we do is we just put 1/6 cos cubed theta, right? But, okay, we didn't start in this particular world. We started out with x, we substituted it with a theta, then we turned it into a u, only to turn it back into a cos, and now the cos has to be turned back into x. So, every time that we see a cos theta, we're going to substitute this particular trigonometric ratio, which means that the cos of theta equals the square root of 1 minus x to the 4th power. So, that is, we are almost there. We are almost there. So, this is going to be equal to -1/2 times square root of 1 minus x to the 4th power plus 1/6. But this is to the, look at this, 3rd power, right? It's like, this is going to make a real mess, so I'm just going to try to make this a little simpler. We're going to put 1 minus x to the 4th power, like this. And this is a square root, but it's also cubed. So it's a cubed square root plus c, and that is the answer, -half. Square root of 1 minus x to the 4th power plus 1/6 of 1 minus x to the 4th power to the 3/2 exponent plus c. Whew. I'm pretty lucid here. Let's get some more alcohol. See you next time on Math AD.